Nimesh Chinoy. Mr. Nimesh has been in the field of application-oriented solutions since 2003. Having 4 years of experience in R&D and 13 years in sales and marketing, he has worked together on developing induction heating applications for welding and preheat and post-heat. He started his manufacturing Indian welding inverters under the brand name of SigmaWeld since 2007. Mr. Nimesh holds double degree in computer science and computer systems engineering from RMIT University, Melbourne, Australia, and is a postgraduate in FMB from SP Jain Institute of Management and Research. Today, Mr. Chinoy will talk about advanced welding power source of MIG, welding and pre-welding induction heating of pipeline industry. So let's welcome Mr. Chinoy.
So we'll start with productivity versus processes. I think Rajshekharan sir covered it. I'll just put a graph out there for you to have a look at. So if you look at arc welding vis-a-vis MIG welding, and this is where we are comparing. So 7018 is the low hydrogen arc welding electrodes, and if you look at 6010, these are typically used in the cellulosic electrodes for the pipeline industry for the root welds. Then you have the low hydrogen double electrodes. Then you have the semi-automatic flux core arc welding. Then you have the semi-automatic flux core arc welding with gas shielding. Then we have the mechanized flux core arc welding. Then you have the automated GMAW, and then you have the automated GMAW with double torch. So this is how the progress has happened over the last couple of years, and you can see the productivity starts from 1 down when you do a manual arc welding up to 7.5 times faster with the latest processes. So when you consider any new project or any welding, what are you considering in costs? And a lot of this Satish has covered, but I'll just take you through. So you need to be more efficient in terms of the welding process. So whether you want to use MIG, flux core, submerged arc, depending on the position of the weld, whether it's vertical down or vertical up. Automation, if the process permits, it will increase your efficiency on the arc on type. That means effectively you will have more productivity. And narrow gap preparation, which Rajshekharan sir covered, which means if you are covering a lesser amount of area, you will be putting in lesser amount of material and covering larger weld place. The type of base metal that you choose, if it's high strength, you need lower the thickness, higher deposition rates, and reduction in welding downtimes, which are due to sputter removals or grinding activities. So if you want to improve your productivity in GMAW or the MIG welding applications, you can move to mechanized MIG welding. Now, as we were sharing before, this is what is meant by a traditional V-groove preparation, and this is what is meant by a narrow or a mechanized groove preparation. You can see there is a good change in the V. This is what the included angle sir was talking about. And this is what it shows, that you will be depositing lesser amount of material, thereby having quicker productivity. So the advantages of going into mechanized is you decrease the volume of weld metal put. This is manual, this is semi-mechanical, and this is, you can see, mechanized solid. So you can see the number of passes keep reducing. Minimal amount of training required for the operators. Optimized mechanical properties of high-strength steel material, consistent quality, reproducible welds, and welder becomes your operator. So as Satish ji was sharing, the right kind of welder is required. Now the welder became the operator, thereby training welder to be an operator is much easier than imparting the skills of getting the right quality of weld done. The kind of welding passes you do in joint is a root pass, a hot pass, a fill up, and a capping pass. Root pass is nothing but the first layer that you weld, and the hot layer is the immediate first pass after the root weld. Subsequently, you will just filling up material, that's called a fill pass, and when you want to finish the joint, you have a capping pass to give you aesthetically beautiful look. So typically you use arc welding or MIG welding for the root and hot pass. Subsequently, you use flux core wires for fill up and capping. Wires, as sir was sharing, which will give you better productivity and faster use. Now, how does all this come back into the equipment or the power sources, and how the speeds have gone up or the advances that have happened in the power sources? This is a typical welding inverter. over the last 20 years, I think inverters have become the norm, and we've moved away from the traditional thyristors and transformers. So I won't dwell too much into the technology of the inverter. What happens next? I mean, what is next level in the power sources? So we are talking about digital power sources, which enable you to have a lot of programming possible, which give you advanced AI inbuilt into the power source, so the welder doesn't have to remember, or his skills are mimicked into the system for ease of welding, and modular technology. So what you saw earlier, this kind of power source or whatever exists today is largely a single power source. So if I was to tell you, it would have one power and one control circuitry. Whereas if something went wrong with that, then you would have to stop the entire setup that you had. With the new technology, what we have is called a modular architecture, which is like a nano. That means within one equipment, you have many small power sources. So typically these come in multiples of 200 amps. So you have a 200 amp power source. If you use 2 modules, you have a 400 amp. You use 3 modules, you have a 600 amp. Similarly, you can go on up to 1000 amps. But imagine you had a 400 amp power source. You don't normally use full 400. You would typically use in the range of 200. If something was to go wrong, your entire setup is not shut. You only are losing 200 amps. You can still weld using 200 amps. So your uptime is high. That's what the change in the technology is all about. It's a modular technology. If you were using a 600 amp machine and there was a problem, you can still use up to 400 amps without having to stop the equipment. And as you would replace a floppy drive or a hard disk on your computer, you simply pull out one of the modules, replace the LAN cable, put it back in, and start welding at full capacity. So your downtime is completely reduced. Another advantage is the cooling is left to right instead of front to back. So traditional machines had the equipment laid out like this, and you would have an airflow coming from back all the way to the front, which means whatever hot components are there at the back, the heated air is cooling the components at the forward. So your duty cycle would reduce. Here you are cooling left to right. So you're only traveling, say, 200 millimeters instead of 700 millimeters. So more cold air available to cool each module, and therefore the uptime is much higher. Longer product life, 100% duty cycle at 40 degrees centigrade. That means you can have non-stop welding, maximum arc on time, and you don't need to plan extra capacity. So if your typical mentality is if you have to weld for 300 amps, you would end up buying a 400 or a 600 amp power source. You no longer need to do that. Buy what you like. So if you were to use 300 amps, buy a 400 amp power source, and you don't need to have surplus capacity planned, which means your connected load will go down, your requirement for electricity will also reduce. What are the other advantages? These machines operate as a CCCV machine. That means they will give you constant current, constant voltage properties. You can do arc welding, TIG welding, MIG welding, all three from the same power source. Of course, for TIG welding, you don't have the high frequency initiation, but all the other features are available. So the quality of weld is very high. The feedback given back to the controller is very quick, and so action takens are much faster. This results in very high efficiency. So you have only 96% efficiency. So for every kilowatt of power you consume, 960 watts are going back into the arc, which means you are consuming maximum, you're losing minimum power and maximum throughput. It's IP34, that means it's very rugged. You can use it on the field as well. Up to 100 programs can be saved in the memory. The digital, what does digital truly mean? Is this only the display is digital, or digital means something else? So digital means it should have faster working calculations and it should reduce the load on the operator. How does it do that? If there's a new guy, so as Satish ji was saying, if the operator isn't trained enough, his hand will shake. If you and me try to weld for the first time, we will not be able to maintain a fixed stick out. Our hand will shake. The equipment takes care of that shaky hand by readjusting the wire speed depending on the arc gap. Why is it able to do it? Because it's operating at 150 kilohertz. By the time you make a mistake, it learns it at every 6.7 microseconds and corrects itself, thereby giving you a spatter-free weld and takes care of the shaky hand. Plus, we have special programs for root welding, for pulse welding, for jet arc, for DAC modulated. So these are different programs which have been preconceived to give you better weld speeds at better features. So I'll just share a couple of them. Now, imagine you are a welder. First thing you need is you want to see the parameters you have set all the time clearly with you. So the display is on the wire feeder itself. This helps you see it very clearly. Second, you are welding a joint which is going, imagine you're welding a box or a bucket. You have to weld straight line and then vertically up or down. You have to keep changing the parameters because the welder doesn't have the ease of changing it. What he does, he sets one parameter and he welds all positions. So you get bad joints or bad quality welds and good quality welds. If you could change the parameters of the welding by only double tapping on the torch, like it's showing you on the screen, the operator is now free to do it at his will without changing. So he preloaded the program, double taps, and he can move forward and reverse. So he doesn't have to go up to the machine. His laziness has been taken care by the equipment and the quality has been taken care by the welder. The welder changes the bright parameters because now he doesn't have to work hard to do that. Second, it's visible to him, closer to him. Saves time and he doesn't require a helper. Second, you have access control. So one of the important features is that you want the welder to weld in the parameters you have defined. It's called a WPS, a welding procedure. You need to follow those parameters. If you don't follow, the welding quality will go haywire. So if you have already predefined them, you can load them in the equipment. You use an RFID card to say that I am a supervisor and I am a welder. When the welder swipes his card, he has only access to limited parameters which have been set. He can only weld. He cannot change, thereby giving you more control over the process and throughput. We also have old parameter locking remotes which were in our traditional equipment to do the same thing. We were able to save one of our customers who was in the auto sector. Their rejection rates were up to 13% per day. We could bring it down to 0.3% per month simply by locking the parameters the welders couldn't change. So if the welder is your regular one or is a contractual welder, you still have no issues because he is welding on the parameters you have set. The need of the hour and what everybody talks about is DMS, IIoT or Industry 4.0. That means whatever you do, the critical parameters should be monitored, logged and seen by somebody else. Here each equipment can relay or transmit this data wirelessly to the server. The antenna captures and puts it on the server and the weld web can show you the statistics up to 40 machines at a time. Who's the welder, what parameter did he weld at, when did he weld, when did he start, when did he stop, what program he was using. All the details are in there. You can analyze your resources, be it manpower, be it your arc on time, be it your job, or be it your equipment. You can monitor them from any given point in time and you would know how much resource is being used. So if they are not used,
can
you can move
sorry
forward.
to interrupt you. Sir, you can wind up in the next couple of minutes, please.
Maybe a minute or two more.
Not much. 2 minutes, right? Fine. Thank you.
Thank you. So here we see improving productivity in MIG welding would be best if you could do root welds with MIG welding directly. You have advanced processes which allow you to show that. So I'm going to show you a couple of videos quickly just to show how it works. As visual is better than talking. So this is how the CSC process works. It's extremely controlled droplet transfer onto the molten pool, which allows you to have very quick control. This is your CSC, what I showed you. This is your traditional pulse welding. This is the traditional root weld, and this is the CSC process. Now, if you can see, these are very high speed camera, which shows you each droplet as it goes and why these programs are useful to you. A quick video to show you how you can weld root welds, or which are very difficult to weld in the open environment. By MIG welding, they are traditionally welded by TIG and then done or with arc welding. Here you can see the root weld directly being welded by the welder using the CSC program. As you can see, there is minimal or no spatter available, and the root welds are much thicker than the traditional welds that you get by MIG welding. This will help you increase your productivity up to about 30%. Ideally suited for root welds, consists of sidewall fusion, less spatter, tolerant to fit-up conditions, and more tolerant to changes in stick-out. Less personal training time and thicker root passes can eliminate the hot problem. That's all we will talk about the welding equipment. I think induction heaters on another day, we can deep dive into that. So just to give you an idea about what are the advances happening in the MIG welding sector. I would stop my presentation there and other to the time given. Thank you so much.